Bismillah ar-Rahman ar-Rahim. This is October 2023 and 42 variant in question number 6. And connected particles concept. A railway engine mass is 120,000 kilogram. Is towing a coach of mass 60,000 kilogram and on an inclined angle alpha to the horizontal. Up till now, what I can understand, and I make the diagram. Very big diagram I have to make. Logic is only one because many forces will act there. So first of all, you can see that which is towing, okay, railway engine. So I make it engine. So this is engine, just for sake of understanding. This is applied force, and this is connected, okay, the bar between them. And this is coach. And naturally, whenever we talk about tension towards each other, for sure that you know it very well. Whenever two particles are connected, tension towards each other, that is for sure. Now this is angle alpha. Now you can see from here, students, or I do one thing, just drag slightly up. Okay, now check it, students. So what is this one? He said here, the driving force is engine applicable is 1, 2. So this applied force, I can write it now here. This applied force, so 1, 2, 5 and 000 newtons. Okay. And he mentioned that a friction force on both given by him. So this friction force, I can mention a friction force acting, this is F, small f, friction force acting on the engine is 22000 newtons. And friction force acting on a coach. So this is friction force, I can tell you, there's a friction force. There's a friction force. Friction force acting on coach is 13000. I think up till here clear. So it means one engine mass and one. Okay, if I ask you what is this is a mass, this one, and you know we formula mg sine theta. We write always mg sine theta. Mass is 1, 2, and 4 zeros. G is 10, and sine theta luckily given here 0.02. We can see clearly. So here I'm writing in the place of complete sine theta 0.02. And this I will multiply. So 1, 2, 4 zeros already we have, and one more zero for that, and 0.02. And I'm getting this one, the weight component of the engine, which is acting downwards. This is, I mentioned, the weight component, and that is a 24,000. Okay, 24,000. I think the idea is very clear. Now, same manner. What is the coach mass? 60,000 kilogram. So what is mg sine theta? I can find it. Weight component acting downwards. So m how much? 60,000. And gravity 10. And sine theta 0.02. So when I say 60,000, 60,000, 4 zeros, one more zero into 0.02, I'm getting 12,000. This is a weight component 1, 2, 000. So I believe all points are very clear. Now, whenever he asks you acceleration and tension, we always make two equations, one for the engine and one for the coach, and solve them simultaneously. So let's start now. Components are very clear. I have make the both frictions, both weight components, and tensions are clear. Now I'm writing one equation for the engine. So I can tell you very clearly, I'm starting from top. Net force equals to MA. Net force is equals to MA. Okay. So 1, 2, 5 and 000. Let me recheck. 1, 2, 5, 000. Okay. And minus. This is I written now this and tension. So I can say minus 2, 4, 000 minus 2 double 2 000 minus tension equals to MA, and mass of the 1, 2, 4 zeros and times to A, basically MA, mass into acceleration. So students, now I can 1, 2, 5 000 minus 2, 4 000 and minus double two triple zero and two triple zero. Sorry, two and triple zero. So I'm getting this. All three forces become 79000. Minus tension equals to 1, 2, and 4 zeros, and equation number 1 done. Now I'm going to make a same story for the coach. So same formula, I'm say wasting time, not wasting time. So because system is going upwards, so I'll start from tension. Tension minus friction minus weight component equals to MA. Tension minus 13,000 minus 12,000 equals to mass. Mass of coach, how much? Is 60,000. 60,000. So when I solve it, 13,000 and plus 12,000, it becomes 25,000. So tension, I'm writing now here, tension minus 25,000 equals to 60,000 A. This is equation number 2. Now students, I'm copying equation number 1 and copy paste below. So when I copy paste below, so students, naturally this tension, negative and positive, they will cancel out. So from 79000, subtract 22500, and I'm getting here 54000. On the other end, 1, 2, 4 zeros and positive 6 and again 4 zeros. I'm getting here 1, 8 and 4 zeros. It will go down and divide, so 3 zeros basically cancel out. So 54 divided by 180, and I'm getting 0.3 acceleration. So Alhamdulillah Rabbil Alameen. So this is my answer. So I believe the point is very clear, and we got the acceleration very clearly, 0.3 acceleration. But question is not over. He's asking tension also. Same value, I plug in either 1 or 2 to get the tension. So I plug in the lower equation here. So I'm getting here 79000 minus tension equal to 1, 2, 4 zeros and times to 0.3. And from here I can get tension. If I type in calculator, I'm getting here 43,000 newtons. So Alhamdulillah Rabbil Alameen, first part completely over. And whenever, make sure he asks you tension and acceleration, we have to make two equations, and you have seen Alhamdulillah Rabbil Alameen. Part number next. At instant when the engine is traveling at a speed of 30, okay, it means the engine. So this speed, the speed of engine is 30. It means whole system is traveling speed of 30. It comes to section of the track inclined upwards. So angle beta, it means maybe upward the angle alpha will change and convert to beta. And the power produced by the engine is this much now. Okay, and as a result, in moving constant speed. Constant speed is obviously, we can say acceleration is equals to 0. Okay, so this part is very clear. So acceleration is 0, students. He is asking that find out that let's say friction forces, how many acting on both engine and the coach. These frictions are remain unchanged. So find out the beta. So story is same almost. Okay, so we have to make it a same diagram. Only the thing is, so I just make the whole diagram once again. See students, saving the time. This question diagram will make the question easy. And check it please. This diagram, I'm going to make it again for the sake of your understanding, because everything is not changing. Only part is changing is this. Okay, what is a engine power working? Where working is a engine is a power. So how many zeros are 5 zeros? And all of you familiar, whenever we have given here force given here, and what is the formula? Power is equals to, or we can say that, yeah, power is equal to FV. This formula we have already available. Power is equal to force into velocity. So if I bring this V under it, I will get applied force. Applied force is a 4, 5 and 5 zeros divided by speed 30. So when I divide it, I will get the applied force. So 4, 5, 0 cancel out. So 4, 5, and then we have a 4 zeros divided by 3, and I got a 15,000. No, 150,000. So this is applied force. So that is why I can write here 1, 5, and 4, 0 applied force. This is applied force, students. Okay, clear. Applied force is given. Now, interesting part, because there's a no acceleration is or tension required. So I will not make two equations. Make sure I will not make two equations. I will make all together as a one system. As a one system, and the what is the formula? Net force is equals to ma, and make no alpha is there. The angle is beta now. Okay, now no, net force equals to ma. But interesting part, the weight component will change as well. Weight component will not anymore remain same, because weight component is what we have basically formula mg sine theta. So look, I'm writing now again 1, 2, 4 zeros. This is a m, g is this, and sine beta. Sine beta, mg sine beta. So I'll write all together. This is behaving like a, so 1, 2, and 4, 5 zeros, and sine beta. This is a we can say here weight component of acting of a we can say that rail, okay, a train engine we can say. So 1, 2, 5 0. So this is, I'm writing here 1, 2, 1, 2, 3, 4, 5, and sine beta. Same approach. What is a weight component of the coach? So we can find the same story, and I'm saving your time by writing here only. This is what is a mass of the coach? 60,000 students. So I'm writing here 60,000 is a very clear. So it means not three zeros, four zeros. Sorry, four zeros all become five zeros, and sine beta. So I'm replacing this as a 60, 1, 2, 3, 4, 5 zeros, and five zeros, and sine beta is a weight component. Now, students, very obvious, we can make it net force equal to ma. So let's start. Applied force on the top is what? Is 1, 5, 1, 2, 3, 4. Okay, let me check once again. Yeah, it is a 4. So applied force minus a weight component of the particle of the engine. I'm writing that as well, which acting below 1, 2, 1, 2, 3, 4. How many zeros? Five zeros, and sine beta. I will not consider tensions. Okay, make sure. I'm including a friction force acting downwards, and that is what? Triple two, triple, double two to triple zeros. And now this is friction also. There's a 1, 3, triple zero. And lastly, weight component of the coach, and equals to 0. So that is what? 6, 1, 2, 3, 4, 5, and sine beta is equals to 0. Why 0? Because constant speed, constant speed. Whenever constant speed comes, so acceleration is 0. Now, students, I can finish my question simply. These two values I will bring on the right hand side. So I'm typing rest part 1, 5, 4, 0, 4 zeros, minus double two, three zeros, minus 1, 3, triple zero, and I'm getting left hand side what number? 1, 1, 5, triple zero. And right hand side what I have? 1, 2, 1, 2, 3, 4, 5, and positive, and 1, 2, 3, 4, 5. And I'm getting here 1, 8, and 5 zeros into sine beta. So this will go down, or I can subtract, cancel three zeros. So 115 divided by 1800. And when I divide it and take sine inverse, when I take a sine inverse, students, so my answer is turned to be 3.663 degree. But after approximate writing this answer, I need, actually it won't be 1 dp always writing. I don't want, so I will add 3.7 degree, and I believe the concept is totally clear, and the complete question is over.